Hello everyone, welcome to the topic Relations and Functions. Here we discuss composition of functions, FOG, GOF and inverse of a function. Consider a function f from r plus 2 close to open interval minus 5 to infinity given by f of x is equal to 9x square plus 6x minus 5. Show that f is invertible with this function f inverse y, which is equal to root of y plus 6 minus 1 upon 3. This time, the domain and codomain are not complete real numbers. Domain is only r plus, which means only positive real numbers. All the negative numbers to be avoided. And the codomain is an interval from minus 5 to infinity. So all numbers below minus 5 should also be avoided. This is the domain, this is the codomain. And the rule given is 9x square plus 6x minus 5. Any element, its image is calculated by this rule. Now, what we are asked to find is, get the inverse function. We are given the inverse function and we need to just verify. But, let us assume that it is not given. Will we be able to get it on our own? We should be. So, we will try to get a G from this codomain to domain such that FOG is identity function and GOF is identity function. Such a G we should find. We are given, of course, but let's not use it. Let's find it on our own. How? Here it goes. Let there be a Y in the codomain. And how do we get its X back? That is what our target. So let Y belong to the range of F. Y is one element from here. If possible, let's write this y as 9x square plus 6x minus 5 using some x. We do not know what x it is. Can we get the x whose image is this y? Can we get that x whose 9x square plus 6x minus 5 came to be equal to y? Let us see whether we are able to solve for x and get this x. How? Here we go. I'm going to simplify this equation. 9x square plus 6x is equal to y plus 5. And I'm going to make a perfect square out of it. 9x square plus 6x. I'll add and subtract a term to make it a perfect square. I add 1 on the LHS, add 1 on the RHS to balance the equation. So that this left hand side now has become 3x plus 1 whole square. 3x plus 1 whole square is a square plus b square plus 2ab. If you apply, you are having these three terms. 9x square, a square. B square is 1 square, that is 1. 2ab, 2 into 3x into 1, 6x. So these three terms equivalent to this perfect square. By this time, RHS has become y plus 6. Now remember, I am solving for x. So 3x plus 1 is equal to square root of y plus 6. This was whole square, now it is 3x plus 1. So what is 3x equal to? Root of y plus 6 minus 1. And what is x equal to? Root of y plus 6 minus 1 upon 3. Here it is. This is the rule we are given. We simply ignored it and prepared it on our own. Now this x, how to get the x from this y? There is a rule now. There is a rule now. Let us take this rule as g function. Take this rule as g of y. Root of y plus 6 minus 1 upon 3, take it as g. Why? We want to show that this g and this f together, when we apply in the composition, they form identity functions. Only then this g can be treated as the inverse of f. Let's see, is it possible? GOF, whether it is identity, I'm going to cross check. GOF of x, let's calculate. GOF of x means G of f of x. That is what the composition says. G of f of x. What is f of x? This polynomial. So let me write G of 9x square plus 6x minus 5. So how do we calculate the G image of this element? This big element has to be applied in place of y to get G of y. So next step will be in this pattern where, because it is G rule. So in this pattern, in place of y, I must put this big expression. So the step will look like this. Root of 9x square plus 6x minus 5, that is the y. Then plus 6. Then outside minus 1 upon 3. This is what G of this element. G of y is this. G of this element is looking like this. Let's simplify it further. Plus 6 minus 5 is plus 1. Inside the under root it is plus 1. So 9x square plus 6x plus 1. Oh, this is that same perfect square. 3x plus 1 whole square. Under the root 3x plus 1 whole square is 3x plus 1. So 3x plus 1 minus 1 upon 3. That makes it 3x by 3. Here it is. It's equal to x. So GOF of x is equal to x. GOF of x is equal to x. What does it mean? This GOF is taking the image of x to x itself. That is, it is an identity function. This is the definition of identity function. GOF is identity. Every element is related to the same element. So GOF is identity function. Also we need to check now, what about FOG? FOG of y is f of g of y. Composition again. Now place what is gy. This is the rule gy. Put this gy here. So f of the gy. Gy I'm using here. Now this element we have to use for the f function. F function says 9 times the square of the element plus 6 times the element minus 5 is the rule. So apply 9 times the square of the element plus 6 times the element minus 5. 9 times the square of the element. Where is the element? The element is this whole thing. Place it here. Place it here. This is the F rule. Look, F rule is 9x square plus 6x minus 5. 9x square plus 6x minus 5. Where x is this expression. This whole thing you place here, place here. Here it goes, here it goes. Now let's simplify further. This whole square makes it 9. 9 cancel. Root of y plus 6 minus 1 whole square. Plus 6 into this. 6 and 3 cancelling. You have a 2 here. Here it goes. 9. Inside it is a square minus 2ab plus b square upon 9. 3 square is 9. And here 6 and 3 cancel. The coefficient is now 2. Now go further. Let's cancel this 9. And root of y plus 6 whole square is y plus 6. Minus twice of root of y plus 6. And here twice of root of y plus 6. Expand this step. 9 got cancelled. Root of y plus 6 whole square is y plus 6. Minus twice of root of y plus 6. Plus 1. Twice of root of y plus 6. Minus 2. Minus 5. Here we can see there are two like terms with opposite signs. Gone. And here 6 plus 1 7. Minus 2 minus 5 minus 7. So ultimately this whole expression is giving you only y. That means FOG of y is equal to y itself. FOG of y is equal to y itself. That means FOG also is acting like identity function. FOG is identity function. GOF is identity function. FOG is identity function. Well, satisfying the definition of inverse. So we conclude, according to this definition, such a g is called the inverse. So the g that we took is the inverse of the given function. This g by itself is the inverse. So f inverse is root of y plus 6 minus 1 upon 3. Hence we proved this function is invertible. Since we got an inverse, it is invertible. With the inverse, this inverse.